Introduction to Virtual Reality and Sensory Perception. Virtual reality, VR, is an immersive technology that creates simulated environments, enabling users to experience a computer-generated world as if it were real. By engaging multiple senses, including sight, sound, and touch, VR tricks our brain into perceiving these digital experiences as authentic. Understanding how VR manipulates our senses provides insight into its applications and potential benefits across various fields. The role of visual cues in VR experiences. Vision plays a critical role in virtual reality, as VR systems use advanced graphics and stereoscopic displays to create three-dimensional environments. By presenting slightly different images to each eye, VR can simulate depth perception, making objects appear closer or farther away. This technique, known as stereopsis, helps users feel as though they are genuinely present in the virtual world, enhancing immersion and realism. Auditory feedback, enhancing the illusion of reality. Sound is another crucial component of virtual reality that significantly impacts our sensory experience. Spatial audio technology allows users to hear sounds coming from specific directions, mimicking real-world acoustics. By incorporating realistic soundscapes that respond to user movements, VR systems deepen immersion and make virtual environments feel more convincing, further tricking the brain into believing in the experience. Haptic feedback, engaging the sense of touch. Haptic feedback adds another layer to the VR experience by simulating the sense of touch. Devices such as gloves, vests, and handheld controllers provide tactile sensations, allowing users to feel virtual objects and environments. By applying pressure, vibration, or temperature changes, these devices can trick the brain into perceiving physical interactions within the virtual world, enhancing realism and emotional engagement. The importance of motion tracking in VR. Motion tracking is essential for creating a responsive and immersive VR experience. Advanced tracking systems monitor the user's head and body movements, allowing the virtual environment to adjust in real time. This seamless integration of movement helps maintain the illusion of reality, as users can look around and interact with their surroundings as they would in the physical world. Accurate motion tracking is crucial for preventing disorientation and motion sickness. The brain's role in processing virtual environments. The brain plays a central role in interpreting sensory information and creating our perception of reality. In VR, the brain receives visual, auditory, and tactile inputs that align with its expectations based on previous experiences. This alignment helps the brain accept the virtual environment as genuine, even though it knows it is not real. As a result, the more convincing the sensory inputs, the more likely users are to feel fully immersed in the experience. Psychological effects, immersion and presence. Virtual reality can elicit powerful psychological responses, including feelings of immersion and presence. Immersion refers to the extent to which a user feels absorbed in the virtual environment, while presence denotes the sensation of being physically located within that environment. These psychological effects are heightened when sensory inputs are carefully crafted to align with real-world experiences, tricking users into feeling they are truly there. Applications of VR in various fields. The ability of virtual reality to manipulate our senses has led to its adoption across diverse sectors. In education, VR can provide interactive learning experiences, while in healthcare, it is used for medical training and therapeutic interventions. Additionally, the entertainment industry leverages VR for immersive gaming and storytelling, highlighting the technology's potential to transform how we engage with content. Ethical considerations and potential risks. While virtual reality offers numerous benefits, it also raises ethical concerns and potential risks. The immersive nature of VR can lead to adverse effects, such as motion sickness, desensitization to real-world experiences, and addiction. It is essential to consider these implications and develop guidelines to ensure responsible usage of VR technology. Conclusion: the fascination of virtual reality. Virtual reality effectively tricks our senses by creating immersive environments that engage sight, sound, and touch. By manipulating sensory inputs, VR offers unique experiences that can transform education, healthcare, and entertainment. As technology advances, understanding the underlying mechanisms of VR and its impact on perception will be crucial for harnessing its potential responsibly and effectively.